Hello and welcome to another session of Decision Science for Operations Management. That is, in fact, our third session on simulation in chapter 12. In two previous sessions, we finished together a complete review on the fact that what is simulation and also what are probability distributions and their relation. And in the second session we had on simulation, we learned together how to generate random numbers, either continuous normal distribution, continuous uniform distribution, or discrete distribution. Today we are going to just do cases together, and it's gonna make your understanding of simulation stronger, because now we are gonna do real cases together. Okay, case one that we are gonna do together is this problem that you see in front of you in this slide. You are a little bit familiar with this case that we are going to discuss and simulate together, because all the examples that we did during the two previous sessions were in fact taken from this case. I did it on purpose because I wanted that when we are doing case one together, many of the parts, including the distributions, including the variables, and several other things, you are already familiar. So the case one is in fact Sanatronics case that you know about. For example, the demand, you know about the part cost, you know about labor cost. And today with this session we are gonna connect all these things together as a real thorough simulation case. Let's read it together. Sanatronics would log an analysis of the first year profit potential of the device. Because of Sanatronics' tight cash flow situation, management is particularly concerned about the potential for a loss. So they want to check it, in fact, for the first year. Of course, simulation would be a very good approach to help them with their decision making. We are going to simulate their profit in 1 year. In fact, we are going to do annual simulation. We do the simulation of annual profit, and after running it for 1000 times, we are going to get the average, we are going to get the standard deviation, and see if the results are in favor of this business. Okay, and now we are here. Sanatronics has identified the key parameters in determining first year profit. Selling price per unit. Because if you remember, in the first session we had on simulation, we said when you want to do a simulation model, you must extract, you must develop the model in terms of the most important or the key parameters and variables in that decision making. Of course, when you want to run a business, the selling price of your unit is very important. For example, when you are thinking about uh, doing farming on the land or on the field, the price of selling of the product that you want to plant on the field is very important, and many times it's the parameter that affect the rest of the decision making, the selling price. And now here, as it makes sense, you see selling price of the product that you make. It is just about the market price. For example, as I told you, for example, you are planning, uh, for example, wheat, and you want to check what is the selling price in the market, and after that you go and check the cost of making these things to see if it works or not. So the selling price per unit is the market price of that product that you want to manufacture, you want to plant, you want to make, so to see if it works or not. Another thing that is of course very important is first year administrative and advertising cost. It is some sort of fixed cost that you have when you run a business. You put some money to assign to advertising and administrative things, and it has no relation, and it is not dependent on the volume of your production or the volume of your sale, and it is just something fixed: administrative and advertising cost. Another thing is direct labor cost per unit, and the another part cost per unit. So each one that you are doing needs labor, needs parts, so all these things cost you, and they are dependent to the number of production that you have. And finally is the demand. These are the main parameters that these people have considered as the most important one in determining if the simulation model can help them or not. But of course, I'm telling you, if since it's a case, it's a standard case, these things that they have extract, of course, they help them with the simulation model, and the simulation model also can help them. Okay, the last paragraph says Sanatronics believes that the direct labor cost would be range from 43 to 47. Now you know it because we have talked about it, and it talks about the parts cost. It's a uniform between 80 and 100. We have talked it, and the last one is about the demand, that it is a normal distribution with the mean of 15,000, and we know the standard deviation is 4,500. Okay, my friends, the most, not the most, but it is important things is about here that I want to uh, attract your attention, ask for your attention. See price per unit and this administrative cost, direct labor cost, and part cost, and demand. 1, 2, 3, 4, 5 items here we have to include in our simulation model, and finally to decide it. And again, I'm telling you, before you do any simulation model, you must extract such parameters as we discussed it in the first week. And when you get the parameters in that way, then you check them if you can apply them in a simulation model or not. But here we can see the selling price very easily can be simulated, administrative and advertising costs the same, direct labor we simulated before, and all the things. So now the stage is ready for us for more work regarding our simulation. Okay, it is now just some sort of review for you because we have discussed these things before, and I told you I did that on purpose because I wanted, when we are doing our first cases, you have a better understanding of the parameters that we are discussing. Okay, so here It is a review. It talks about the probability distribution of uh, direct labor cost, and it says it ranges between 43 and 47 and with different probabilities. So whenever we assign a parameter a probability distribution, or when we assign a variable a probability distribution, we should know that that is part of the simulation in terms of um, generating random numbers. Because sometimes, although a parameter is very important in the simulation model, but its value is fixed. So there is no need for generation of random number for that thing because it is fixed. But here, when it says it is discrete, this probability distribution, and it shows you the graph that you see in front of you now, it means that we need to have a column related to direct labor cost per unit to be simulated. The next things that we have is about parts cost per unit, and it says it is a uniform continuous probability distribution between 80 and 100. The reason I'm passing these descriptions that you see here because we have discussed these things the previous session, and I want to get to that simulation stage sooner, so I passed them. So again, the same description I gave you about the labor cost applies here. We need a column in our simulation model regarding the parts cost per unit. And the last one, the last random number, the random variable that we have is regarding the demand. It says the demand follows normal distribution. As you can see in front of you, the same description I gave you regarding the two previous probability distribution applies here. So in our simulation model, we also need an independent column for number of units sold or demand, while in this column, random numbers are generated. You may ask, what if the demand was fixed? Did we have to, in that situation, assign it an independent column? Since it is fixed, no, it is not necessary, but still you can assign uh, an independent column, but in that column it would be only one number, that is the demand. We are going to discuss these things today uh, with each other. Okay, let's do activity 1 together. Activity 1 says review again the simulation challenge Sanatronics is facing. Make sure you know everything about this problem before you proceed from different viewpoints of a manager, an accountant, and a decision scientist. So please go back to the description of the case we just discussed and make sure you are 100% okay with that. Even though you feel you are completely dominant on the problem, but I just want to give you that confidence and dominance on the problem that we are gonna simulate together. So check it, and for example, when it says uh, make sure you are fine with it from different viewpoints of a manager, accountant, and decision scientist, just try to check it as a manager. For example, you own the company and you want decision scientists to do this analysis for you, an accountant about the numbers and all those factors like demand, cost, part, and decision scientist as a simulator.